Design and evaluation of a silent speech-based selection method for eye gaze pointing. Dwell and speech are the most used hands-free selection method in eye gaze pointing. However, dwell is time-consuming, erroneous, and causes irritation and fatigue. Speech is unreliable in noisy places, compromises privacy and security when around strangers, and inaccessible to people with speech disorders. We studied the feasibility of using silent speech as a hands-free selection method in eye gaze pointing. Silent speech is an image-based language processing method that interprets users' lip movements into text. Silent speech does not require the use of external hardware since both eye tracking and silent speech recognition can occur through a webcam. Silent speech does not rely on acoustic features, thus can be used in noisy places or in places where people do not want to be disturbed. Silent speech is also more inclusive since it can be used by people who cannot vocalize. To recognize silent speech commands, we developed a stripped-down image-based model. Evaluation revealed that the model can recognize silent speech commands in about 2 seconds, which is comparable to a state-of-the-art speech recognition model. We combined our model with an existing eye tracking model Gaze Cloud API, to enable users to point at a target using eye gaze, and silently speaks the command select to select it. We compared silent speech with dwell and speech in a Fitts law study. Results revealed that speech and silent speech are comparable in throughput and selection time, but silent speech is significantly more accurate than the other methods. Participants were significantly more enthusiastic about using silent speech than the other methods. We conducted a follow-up study to investigate the most effective screen areas for eye gaze pointing. Results revealed that target selection around the center is significantly faster and more accurate, while around the top corners and the bottom are relatively slower and error-prone. Selecting small targets with eye gaze, especially when they are closer together, like in a menu, is slow and error-prone. Hence, we extended the design by adopting target gravity and 6 silent speech commands to facilitate menu selection. Target gravity uses a snap to effect to lock the cursor to the center of the target if the cursor is within 10 pixels of the target. The 6 silent speech commands enable horizontal and vertical cursor positioning and target selection. Right moves the cursor to the right item. Left moves the cursor to the left item. Bottom moves the cursor 1 item below the current item. Top moves the cursor 1 item above the current item. Select selects the current item. Exceeding the 10 pixels threshold unlocks the cursor by releasing target gravity. In a comparative evaluation, the method with silent commands was 9% faster and 96% more accurate than without commands. Participants found the method with silent commands significantly better in terms of performance, usability, and perceived workload.